Alright guys, I hope you're seeing all my updates. We had a lot of new information come down the pike this afternoon from administration about the timing and schedules and things like that, so we got to kind of hurry things along. But what that means on your end is I'm going to be uploading more lessons for you guys to work through the week, and we've got to get through space exploration in 2 weeks, and we can. You'll be alright. The biggest crunch is going to be getting through this hopefully by sometime this weekend, maybe. But if you need a few more days into next week, take it. I'd rather you guys get it done than turn it in half done. You know what I'm saying? All right, so let's get cranking. So we were talking about stars, okay? And there's just some info here to work with. We're going to answer number 26 and 27 in your notes in a couple minutes. But just some things to look at that are worth reviewing. Okay, so we had our red giant and then we had our super giant, right? So there's different things that go on in their lifetime of those two types of stars that we want to look at. Okay, so the red giant, that's what our star is going to eventually become based on what it's burning. Okay, so the outer layer of the star goes off. All right, it just sheds it off. Okay, now the core stays there. So this event right here is kind of like it just going a little pop, okay, of a star, right? It just goes, right, and the outer shell just burns off. So what you're talking about that is photosphere and the chromosphere, all that, everything outside the radiation zone, remember the radiative zone, off. It just sheds it, and all you're left with is the core. And because it's still on fire, still burning, it becomes this white dwarf. It's shrunk in its size. It hasn't shrunk, okay, but what you're looking at is half the size of what it was before. And it's just the core that's burning. So it becomes a white dwarf, and then as it cools down, it becomes that brown dwarf and then the black, right? So let's look at stars that are 4 to 8 times larger than ours, okay? Now, they're already big. So what happens is, as the star goes through its life cycle, it eventually just, instead of a little pop, a little right? This is a right? And the whole thing just explodes off the outer layer of the star. But because it's so big, think about it. The core has to be big as well. And it can't hold itself together, and all that mass in the core has a tremendous amount of gravity, so it pulls everything in, and the whole thing just collapses. And you got, now this is a weird one. If you take me for physical science, you're going to hear about this in the future. But protons and an electron bond together to form a neutron, right? Proton's positive, electron's negative, right? It becomes a neutron, no charge. And so that's where you get the concept of a neutron star, okay? We're not filling in anything, we're just talking through this, okay? Now, what if this thing is like 9, 15, even 20 times the size? Well, that thing just explodes in a supernova. I mean, forget the outer wrapping. The whole thing just explodes in a supernova. It's one of the most bright, brilliant things that happens in the universe. But the core is left. I wish we had 3 or 4 days that we could really spend on black holes. We just don't. But a black hole is basically the dead core of a star that went supernova. Again, I wish we could spend days on this, but let's stop and think about it a minute. If the core of this thing is not burning, and it's immense, don't get me wrong, it's huge. Yes, it has a lot of gravity, but isn't it just something solid? Because there's all this conjecture out there about, does a black hole lead you to another dimension? Maybe because of the speed you're going, yeah, but I'll just leave that one there. The core, it's dead. It's a dead lump of coal sitting out there in space with a tremendous amount of gravity. All right, want to look at something next. This is exactly what I was just talking about, but this is in picture form. Let's look at it from the top. We got the average size star. It swells into a red giant. Average is just your plain old giant. right? The outside pops off, the core's still burning, it's a white dwarf. Okay, let's look at the massive star. Remember the massive star, much, much bigger than your average. It swells up to a super, right, massive, super giant, and it just explodes. It can't even hold itself together anymore. And you end up with a neutron star or black hole. Okay, now take a minute and look at these two charts. Remember, average giant, right, red giant. The outside pops away, white dwarf, I don't know why it says giraffe, that's stupid. White dwarf. But then we have our massive stars that become the red supergiants. And the whole thing just explodes, and you've got your two different types of star, neutron star or a black hole. That ought to help you with 26 and 27.